Okay, this is number 27 from Are You Ready for Calculus? And these are kind of important. We're using what we call the symmetric difference quotient. And this is actually a very big part of the definition of derivatives. When we get to that, you'll be seeing these. And basically, we're going to take different functions and put them in this formula, f of x plus h minus f of x over h. So you have to kind of understand your function notation. And we'll go through this step by step so you can see what's going on. So basically, the x is right here, so f of x means, this is kind of like a rule which says just 2 times me plus 3, whatever is in here is the me. In this case, the me is x plus h. So when I put f of x plus h, and I have basically 2 times x plus h plus 3. That's f of x plus h. So there's my 2 times x plus 3, except my x now is x plus h. All right, so 2 times me plus 3 minus, and this is f of x, so that's 2 times x plus 3 all over h. Then we multiply out 2x plus 2h plus 3, negative 2x, negative 3. The x terms cancel, the numerical terms cancel, so we just have 2h over h, which is just 2, so that simplifies real nice. So make sure you kind of understand what to do over here. Now the next section, the next one, letter b, it's a little more complicated. Here my function is 1 over x plus 1. All right, so this f of x is 1 over me plus 1. So if I'm going to say f of x plus h, that's going to be 1 over x plus h plus 1. 1 over me plus 1. So when I put this in, I have this 1 over x plus h plus 1 minus the original function 1 over x plus 1 all over h. And now we have a complex fraction. So in order to deal with this complex fraction, remember we had that shortcut we talked about earlier. We multiply the top and the bottom by the LCD, which is just this factor times this factor. All right, so it's x plus h. Hope you can see that. Zoom in a little bit. I hope that would work. You can see there's your least common denominator. Okay, x plus h plus 1 times x plus 1. I multiply the top and the bottom by that. When I multiply this term by that, this trinomial cancels, so I've got x plus 1. This binomial cancels, and I got the trinomial x plus 1 plus h all over h. Okay, and then see that does it really fast. That's why we know this. That's why we use this little shortcut, because we run into a lot of these. Okay, then what I can do is I can simplify, so I can remove the parentheses. So I've got negative x, negative h, negative 1. I'll zoom out a little bit here so you can see that. And then what happens here, the x's cancel and the 1's cancel. So I end up with just negative h all over the same denominator. And then you can see what happens. The h's cancel, so we just end up with negative 1 over, and this is the trinomial. Move this over so you can see that. So again, the h's cancel, so we got negative 1 over just the trinomial x plus h plus 1 times the binomial x plus 1. There's your final answer. Okay. And then the last one, and this is a pretty common example, so make sure you're up on these because these are very important, and especially the first part of the book. In this case, f of x is x squared, so this just says square me. So I've got x plus h, so that's just going to be square x plus h, square me. So x plus h squared minus x squared over h. If I square this binomial, it's real easy, just x squared plus 2xh plus h squared. We'll do a lot of these binomials. Minus the original function x squared all over h. And notice the x squareds cancel. So I've got 2hx plus h squared over h. And then we'll factor out an h, and we'll cancel the h, and we end up with 2xh. And we do a lot of this, so make sure you kind of are aware of what's going on. Okay, hope that helps.